Hey, it's Josiah. Welcome to this fourth and final little segment of putting your R model into production. So in the first video, we went over what APIs are. Second video, we reviewed what functions are. The third one, we reviewed how to actually make an API. And this one is calling the API. I think a lot of times we talk about how to make an API or make something into an API, but we kind of forget that we need to call it too. So I don't want to leave you hanging with that. The package httr is what we're going to use to accomplish this goal. It's one of my favorite packages. That's partly because I'm kind of obsessed with APIs and I think they're the coolest thing ever. So in order to work with an API or make requests to it and get the response back from it, there is a series of steps that we need to follow, and it's pretty much the same for any language that you're going to work with. The first step is generate the query URL. The second step is to make the request. And the third is to parse the response. It seems kind of simple. So the first thing we need to do is create the URL. And I'm going to create an object that contains the base of the URL. So the thing that's not going to vary, the thing that's fixed. And then we're going to create a named list with parameters and values that we're going to pass in as parameters to the query URL. If you recall, there's kind of that format in the query URL where it has a question mark, the name of the parameter, equals, and the value. So this params list is going to be used in combination with a function called modify_URL from the httr library to create this query URL that we're going to send as our API query. Here you can see we're creating this object BURL that contains the host name. So here it's 127.0.0.1, which is our local host. And then we're using the port number 5022 and then specifying the endpoint median income. Here we're creating a named list with as many elements as there are parameters in our API. The first one's going to be called prop white, and the second one's called attain edu rate. These need to match the parameters that we have in our API. Okay, otherwise the API query won't work. The next thing we need to do is actually send the request, and within the httr library, there is one function for every HTTP request type there is. In the practice of writing HTTP requests is using all caps. So likewise, the functions from the R packages are using all caps. And here we can see that we've kind of sent this query to the API, and now we have this response object called resp. And when we print it out, we see this kind of block of text. It tells us the date, the status, the content type, and the size. And the status is really important. It says 200. That means our query worked. If you saw 400 or anything starting with 400, it didn't work. So now we have this. We need to actually extract the values from inside of it. And to do that, we're going to use the function content on the response object. And I also want to specify the argument value as equals text. Otherwise, the httr library is going to do its best to parse it, and it often ends up in a list object, and that can get a little hard to work with. So if we type as text, we're going to get the raw JSON from the API. And with the JSON string, there's this really awesome package called JSON Lite, which parses JSON. And there's a function from it called from_JSON, where if you provide a string that contains JSON, it kind of turns it into an R object. So that's really awesome. And that's all it takes is to call your API. So let's actually just get into it and illustrate how to do this from the IDE. This is our API that we created in the last video. It should look familiar. If not, you can go back to the last video and watch it. But before we do anything, I want to show you this trick here. Within Plumber, there is a function called plum. The argument it takes is the path name to a Plumber API R script. So in our working directory, we see we have one called plumber.r, so I'm passing that path here. This creates an R6 object that we can use to spin up that API. And if we run it, we can specify two arguments, host and port, so we can have more control over where this API will be spun up. Because every time we click Run API, RStudio IDE chooses a different port. We can run it again. We see, oh, it did it consistently there. That's nice. But here, if we do this, it's going to run on that 127 localhost, and then also port 5022. This is nice. But the challenge here is that our R session is being occupied by our API. So we can't actually send queries to this while we're running it from our R session. So the trick here is we're going to close this session, API for the time being, and we're going to use the jobs launcher. If you don't have this feature yet, it's time to update your IDE. That means you're on version 1.1 or earlier. So make sure you update your IDE so you have this. What we're going to do is we're going to type start local job, and this is going to run an R script in a background R session. That's going to free up our current session to do work with it. So now I'm going to point to the R script, the run plumber R script, so it can run this API in the background. And then make sure it has the working directory that we're in, which it does. Deploying R models. Perfect. So now we're going to start it, and we can see that the API is running on localhost at 5022. And now we can start working with the API. So if we copy this URL, we can see our documentation, so we know it's running and it's live. Okay, so let's get to work. We're going to load the httr library. And then we're going to create our base URL, which is going to be a combination of, oopsie, it's not that one, where the API is living right now, and the endpoint we're interested in, which I think is called median income. Let's double check. Median income. Perfect. Okay, so now we're going to create this object which contains an element for each parameter that we need to specify. So our parameters that we need to specify are prop white and attain edu rate. So prop white, I'm going to choose a random value of 1/4, and then attain edu rates, I'm going to choose for 3/4. And now we have this named list that we can call kind of as if it were a data frame where we have these different elements that we can call. This is super helpful. And if you don't know much about named lists, I really recommend you kind of learn about them. They're really, really useful. Okay, so now we have this function modify URL that we need to use to create that query string. So the first argument is URL equals the base URL, and then the argument is called query. This is going to fill in our query parameters. Query equals params. So now when we do this, it fills in the parameters as they should be, so that if we take this URL and go to our Chrome browser or our browser, we get the JSON response back, which is beautiful. So now I'm going to say this is an object called query URL, and we can make that request now. Query URL, and call this resp for response. And now if you see here, we have this object called response. Status 200, it worked, beautiful. So we need to extract the value from this response. And as illustrated in the slides, we're going to use the content function. And when we run this as is, it turns into a list. And we can extract that by just plucking the first element if we wanted to. But I want to be a little bit more careful in my approach. So I'm going to just specify the as argument and say, I want the raw text. And it gives us a warning saying no encoding supplied, defaulting to UTF-8. And I want to avoid that argument, that warning in the future. So I'm going to say encoding equals UTF-8. And that warning disappeared. Lovely, but we still get this raw JSON. So I'm going to call this resp raw. And we still have this character string, right? Like I can't take this and divide it by 2 because it's a string. So we need to extract this. And we're going to use JSON light from JSON. And now we have this object. And now we can do regular math with it. Perfect. But this same pattern that we saw in the second video is occurring right now, where there are values that we want to change on a frequent basis, and maybe we want to make some shortcuts around this code. So this is a really good sign that we want to create a function. So here we're going to create a function called get income preds, and it's going to have 2 arguments because that's what we're required to send to our API. Prop white attain, I'm going to call it edu rate because I'm feeling a little lazy. and then our body. If we wanted, we can specify some default values of like 0, for example. So I'll do that right now. And then I'm just going to copy and paste this smack dab into the middle of this body and just fill in the arguments where they should have been placeholders. So prop weight. And then this is going to be equal to edu rate. And then now I can define this function and send some, yeah, there we go. It works. So I can say 1 and 0 or 1 and 1 and perfect. So now we've created an API wrapper around the Plumber API that we just created. This is awesome. So now we can take this API and host it on something like RStudio Connect, on your own Docker image or something like that. So you can have this persistent API that can be called whenever you need. And since it's using HTTP requests, people from Python, Ruby, Scala, Java, and whatever can call that API. So now you've built this infrastructure that you can use to kind of take your model and put it into a production environment. Thank you for kind of joining me on this little journey. I hope it was helpful. If you have any questions, just comment below and I'll get to you as I can. Thanks.